Hello friends, let us discuss the questions of AP Physics C 2021 mechanics. Right? We will discuss question number 1 of set 1. So let us see the question of AP Physics C 2021. Let us see. In this video, we will discuss question number 1. So first of all, let us read the question and understand it. So the question is, a 0.5 kg fan, just a minute. The question is a 0.5 kg fan cart. So this is 0.5 kg fan cart is placed on a level horizontal track of negligible friction. So the coefficient of friction of this part will be 0. This is the horizontal track. As you can see, the fan is turned on and the fan cart is released from rest. So its initial velocity will be 0. It is released from rest as it is written in the question and moves to the right. So fan will apply the air in towards the left and the cart will move towards the right as the friction is 0. Since there is no frictional force, so whatever the force exerted due to the fan, this cart will move for sure, right? Because there is no any frictional force. So any imbalance in this cart will produce the motion. Okay, so the cart travel towards the cart travel along the horizontal track and then down an incline. So after some time it travel horizontal distance and after that it will move on this inclined plane, right? Motion 1 detector measures the acceleration a of the cart at time from time t is equal to 0 to t is equal to 3 seconds. So this is the motion detector 1. It detects the motion t is equal to 0 to t is equal to 3 seconds. At t is equal to 3 seconds, the cart makes a smooth transition to the incline. Okay, so at t is equal to 3 seconds, the cart is going to the inclined plane and the motion detector 2 measures the acceleration of the cart after the 3 second. So after this 3 second, the motion is detected by the motion detector 2. The fan exerts the same magnitude of force on the cart during the entire motion. So the fan is exerting the constant force throughout the situation, throughout both the situations. So the fan exerts the same magnitude of force on the car during the entire motion. The graph below show a as a function of t. So there will be a graph below this paragraph in which we have acceleration and time on the x-axis. So for each motion detector, the positive direction is away from the detector. So the positive direction of motion will be away from the detector. So this will be its positive direction and this will be its positive direction. Okay, friends. So let us see the graph of, so this is the motion detector 1 and this is the response of motion detector 2. So this is the acceleration a1 versus time and this is the acceleration a2 versus time. This will be from 0 to 3 seconds. This will be 3 to 5 seconds. So what's the question? The question is, on the dots below that represent the cart at two different locations, draw and level the force, not the components. We have to draw only the force that acts on the cart at each location. Each force must be represented by distinct arrow stating on and pointing away from the dot. So we have to basically draw the free body diagram. Let us see on the question first. See, what will be forces here? As you can think, there will be a downward, there will be a downward force of mg. M is the mass of the cart, including fan, and g will be the acceleration due to the gravity. So this will be the mg. There will be a force on horizontal direction due to which it starts moving, and let us suppose we named it F air. Yeah, F fan, right? And also there will be a normal force acting vertically upward, that is the F normal, right friends? So this will be the free body diagram on horizontal track. What will happen to the inclined plane? I am trying to explain you on this question paper. After that we will finally draw on the answer sheet paper, right? So because this will be easy to understand what's actually happening. So at the inclined plane there will be a mg force acting downward. So let us suppose this is mg, again same mass and acceleration due to gravity, that is a g. There will be a force F air, F fan, and there will be a normal force, that is the F n. Sorry, we have done some mistake. Mg will be acting vertically downward. So we should draw it like this. This is mg, right? This is F fan and this is F normal. We have to draw only the forces, not the component. So this is the scenario of this question. You can easily understand in this diagram. Let us draw this final answer on required place. So cart on the horizontal track. So we understood on the horizontal track there will be a force mg, there will be a force F fan, there will be a force F normal. And similarly, on the inclined plane, there will be a force mg downward, there will be a force F air, and or we can say F fan, and there will be a normal force, that is the Fn. Okay, so this completes our first question. Let us see the second question. Calculate the magnitude of the net force exerted on the fan cart when it is on the horizontal track. So when the cart is on the horizontal track, we have to find the magnitude of the net force experienced on the fan cart. So this is the situation of horizontal track, right? So we have to find magnitude of the net force. See, this force and this force will cancel each other. Why? Because the cart is going in the horizontal direction. So the net force in the vertical direction should be zero, right? Since cart is going in horizontal direction. So in vertical direction, so in vertical direction, there should be net force 0. There will be no any force in the vertical direction. So for horizontal direction, we have to find F fan, and that should be equal to mass into acceleration, right friends? So what will be the mass? We have given the mass. Mass is 0.5 kg. And what's the acceleration? Let us read the acceleration. For the acceleration, we have given this graph. See, this is the acceleration versus time graph. And as we can see, this acceleration is constant throughout 0 to 3 seconds. Our acceleration is constant. So we can easily find the force by ma. Force is equal to ma. If our acceleration is constant, see friends, what will be the formula of force? It depends on your acceleration. If acceleration is constant, then you can easily apply this formula. If acceleration is your variable, then we have to integrate. We have to find it by integration, right? These are the basic concepts. Since the acceleration is constant, we can directly find the force by F is equal to ma. So what is the acceleration? How we can find the value of acceleration? To find the value of acceleration, please note, here it is 0, here it is 2. So there is a gap of 2. So 2 upon how many intervals? 1, 2, 3, 4, 5. There are 5 intervals. So the value of each interval will be 2 upon 5. And as you can see, there are 2 blocks. So we have to multiply by 2. So that is a 4 by 5. So the acceleration will be 4 by 5. That is equal to 0.8. And the unit is given meter per second square. So let us put this value on the question paper. So the net force will be 0.5 into 0.8 meter per second square. And what we will get? We will get 0.40 Newton. This complete our second question. Okay, friends, let us see the third part. That is the C part. The question is calculate the angle theta of the inclination. So let us suppose this is the angle theta, right, friends? This is angle theta, right? So again, we can we can break the components of this mg. As we can see, this will be mg cos theta, and along this there will be another force, that is the mg sin theta. There will be a component of mg, that is the mg sin theta. We know this very well. Along the inclined plane, the component of mg will be mg cos theta and mg sin theta. Mg sin theta will be along the inclined plane, and mg cos theta will be perpendicular to the inclined plane. So again, this mg cos theta and this fn will cancel each other, right? Because block is moving, or our cart is moving along the inclined plane, not perpendicular to the inclined plane, right? So the net force will be, we have to find the inclination. So the for the inclination we can write f fan plus mg sin theta should be equal to net force, that is the mass into acceleration a2. This is the net force, or we can write first mg sin theta plus f fan should be equal to f net, right? And what should be f net? See, this acceleration is overall final acceleration, overall final acceleration for time t is equal to 3 to t is equal to 5 seconds. So this is the acceleration for the time 3 to 5 seconds. And what it will be? It will be, let us read it. So this is -2 and 1 block more. So what the value of 1 block will be 2 by 5, right? So this will be -2 minus, yeah, or plus of -2 by 5. This will be, so it will be -12 by 5 meter per second, right? So let us, so why it is -12 by 5? Because the, as you can see in the inclined plane, the question is saying the positive direction is away from the detector. So positive direction is this, positive direction is this along the inclined plane. So the negative acceleration means the acceleration is actually downward. So that's why this is negative. As you can see in the question paper, I have also explained this. The positive direction will be this, away from the detector. So the negative acceleration means actually acceleration is in downward direction. This is the actual direction of A2, and that should be, right? So we know the value of acceleration, that is A2 should be equal to 12 by 5. So what will be the net force? Net force during this inclined plane motion, that is the mass multiplied by acceleration, that should be the net force. So we can equate it here, that is equal to mass into this, right? We have ignored the minus sign because the direction calculation is already done here, right? We have already taken the direction of f air and mg sin theta, and we know the direction of A2 should be in this direction. Okay, so let us calculate this. F fan, we know the value of F fan, that is the 0.4, and that is the constant according to question, that is constant. So we have to find theta. Let us calculate it. Mg sine theta should be equal to F net minus F fan, that should be equal to Ma2 minus Ma1. If you put here, that will be the A1 for the first part. Okay, friends. So you can write M common. This is the A2 minus A1, right? So what will be the sine theta? So sine theta will be equal to, that is the M A2 minus A1 whole divided by mg. So m and m gets cancelled out. So this will be A2 minus A1. And what is the A2 minus A1? A2 is 12 by 5 minus A1 is 0.8 divided by 9.8, this much of sine theta. So what will be this? And what will be theta? Theta will be sine inverse of this value. Let us calculate it. 12 by 5, just a minute. 12 by 5, sorry, 12 upon 5, that is equal to 2.4. So this is 2.4 minus 0.8 upon 9.8. So this will be 0.8, this divided by 9.8. So this will be theta is equal to sine inverse 0.163. So sine inverse 0.163. So this is theta is equal to 9.38, or you can approximate it 9.4 degrees. So this is basically the inclination theta. I hope you understood this explanation. If there will be any doubt, you may do comment in the comment section. Okay, friends. So let us see question number part B. Suppose careful measurement determines the angles of the inclination to be 3 degree larger than the calculated in part C. So the question is saying, just a minute. So the question is saying, suppose careful measurement determine, so the determined value of theta determined is 3 degree larger than the calculated. So 9.4 degrees plus 3 degrees, that is equal to 12.4 degrees, right? Then the calculated in part C. Consider the following explanation. So the question is saying the determined value of theta is 12.4 degree, that is a 3 degree greater than the calculated value. And the question is giving some explanation to these type of error. So the scale used to measure the mass of fan card was not calibrated properly. So the question is saying the scale used to measure the mass of the fan card was not calibrated properly, right, before the measurement, and this could be the account for the observed difference in the angle. So the question is saying basically due to the error in measurement of mass of the fan card, this error is coming. 3 degree larger is the error, and this is due to the mass of the fan card. So the question is asking, does the explanation sufficiently account for the observed discrepancy? So is it true to say this? So let us see. I have already explained the expression for sine theta. Please see the expression for sine theta. This, just a minute. Please see the expression for sine theta. Right. As you can see, the expression of sine theta is, that is equal to A2 minus A1 upon G. This is independent of mass of card. As you can see clearly, this is independent of mass of card. This is independent of mass of fan cart, right? So this should not be the correct explanation for this error. So we you can write no. Justify your answer. So we have given a justification for this answer. So I think this question is completed. No. So the experiment is repeated for several trials, each with a different angles for incline, right? For different angles for incline, the acceleration of the cart down the incline is measured for each angle, right? So the acceleration of the cart down the incline. So during the inclination, the acceleration is measured. So actually, this is the A2, right? The graph below shows the plot of the acceleration A of the cart as a function of sine theta. So we know the value of sine theta was, the expression for sine theta was A2 minus A1 upon G. We have derived this. So this is the graph of A2 and this is the sine theta. So sine theta is basically your X variable and A2 is basically Y variable. So if you want to plot this graph from this expression, so this is basically your X, this is your Y minus A1 upon G. So what will be the value of Y? We can express it. So XG plus A1 should be equal to Y, or we can write Y is equal to GX plus A1, right? If you compare it with Y is equal to MX plus C, if you compare it Y is equal to MX plus C, so we can see easily. So slope is basically G and intercept is basically A1, right? So what's the question is saying? The question is draw a best fit line for the data. So we can draw the best fit line. Just a minute. So I think, see, this is not best fit. This may be a best fit, right? So this is the best fit. So this part completed. Next part is, just a minute. So this will be actually not fixed. So first read the next part. Using the straight line, calculate an experimental value for the acceleration due to gravity. We have to find the experimental value due to the gravity. So we can calculate it easily. We have to find the value of G. So how we can find G? G is basically the slope of this curve. And how we can find the slope? How we can find the slope? For the slope, we have to take 2 point and we can find the slope. That is the change in Y upon change in X. Let us take 2 points. So what will be the slope? Let's take 2 points. Any two easy points we can take. We may take first of all this point. So y2 minus y1 upon x2 minus x1. So so this is our second point. And let us take any another first point. Let's take this point, right? So y2 is basically 6. So 6 minus, see, 1, 2, 3, 4, 5. So one part is basically 1 upon 5. So this is, that is equal to 0.2. So this is 0.4. So 1.4. So 1.4 upon x2 minus x1. What will be the x2? X2 will be 0.5 minus x1 will be, see, 0.1 divided by 1, 2, 3, 4, 5. 5 into 4, right? So this will be, just a minute, 0.1 into 4, 0.1 into 4, this divided by 5, that is equal to 0.08. 0.08. So this will be 0.08 Let us do this calculation. So this will be 6 minus 1.4, that is equal to 4.6 divided by zero point 0.5 minus 0.08, that is equal to 0.42, and 4.6 divided by 0.42, that is equal to 10.95 meter per second square. So this is the approximate calculated value of this G. Let us see the next part, if any. If the cart were replaced with the second cart, just a minute. So if the cart were replaced with a second cart of mass 1.0 kg that has the fan that exerts the same magnitude of the force as the original fan, explain how the graph given in part E would change. So let us see the part E. So this our baseline fit was along this, as you can see in previous time snap. So how this graph will change? So how this graph will change? So as we know, the graph will be y is equal to mx plus c, and the equation was y is equal to gx plus a1, y is equal to gx plus a1, y is equal to gx plus a1, right? So what will happen if the, see, previous mass was 0.5 kg and the new mass was 1 kg. So what will happen? See, what will be a1? What is the a1? A1 was intercept. This is intercept, right? And its expression was intercept a1. We know force was m into a1. So what was a1? A1 was F upon m. If you increase the mass, so a1 will decrease. If a1 will decrease, so intercept will decrease. So if intercept will decrease, the, see, let us suppose first graph will be like this. So intercept is here. Let us suppose this is a1. If intercept will decrease, it will shift downward. This is the new intercept, a1 dash. So as you can understood this explanation, so you can write, as mass increases, as mass increases, a1 will decrease, that is the intercept will decrease, intercept will decrease. So what will happen? Slope will not change. Slope is basically g, that's the constant. Slope will unchanged. Slope will unchanged. So what will happen? The new line will be parallel to old one and decreased intercept. Okay, friends, I hope now this question will completed. Yes, this question is completed now. So if there is any doubt, any problem, please comment. I will reply as soon as possible. And for the next question, please watch our next video. Thanks for watching.